PPU is the only known technique to solve parallel problems with a lot of dependencies. Every other so far represented structure having big problems when the memory calls are dependent.
The specific problem that I would like to see flow computing to solve is the efficient parallel memory access, parallel shared memory access that is independent of, say, access patterns.
We basically would like to solve these the problems that the current technologies are having in terms of just the performance, or the CPU being the weakest link in computation. So there's a lot of use cases that are now starting to suffer because of the CPUs. Next year we would like to get our commercial beta for parallel processing in the PPU ready. So we want to show the world that we could get more than 2 times improved performance with CPUs that are equipped with PPU, and then having this also showing that there would be 100 times faster potential for optimized use cases, and both with full use cases, so full industrial efficiency use cases that would solve that one. And we'd like also during the next year, so we'll get the lead customers in line and committed and start co-developing the future CPUs with PPU together with them.
The PPU aims to fill the gap between the user, the medium user, and the parallel programming world. I really believe that the PPU, if implemented inside standard processors, is able to provide a much faster experience to the end users.
One of the things Flow is, I think, is going to tackle is the accessibility of parallel computation, because nowadays we have multi-core systems, multi-core CPUs that don't scale efficiently for parallel tasks, whereas GPUs they do scale well, but they are originally designed for graphics.
I'm always drawn towards new ways of doing things. You know, there's a lot of people doing things exactly the same way, different variations on the same way. It's quite refreshing to see someone with a completely different approach, and I think Flow's approach is a completely different approach to the parallel computing problem. One of the proposals of Flow is that we'll take your unstructured code and we'll potentially boost it by up to 2 times, giving you 2 times the performance. So I'm quite excited to be writing the compiler that will enable that boost in performance, and I think combined with the PPU's ability to be introduced with any kind of CPU architecture makes it a very powerful combination. We could potentially boost the performance everywhere just through the tech stack. We can write parallel programs. You have multi-core systems and you have GPU or vector machines, but they both come with different trade-offs and performance benefits that you kind of have to weigh up. I find that Flow's architecture is a nice combination of the two, giving you the best of both worlds for the minimal amount of drawback.
The strongest problem I hope that the parallel processing unit will solve is giving a way to execute calculations that have inner dependencies in the pipeline, where the part of the computation depends on a previous calculation for the same equation, let's say. So I hope that by the time 2025 is over, is that we can take like a small piece of code and have it run on tens of thousands of data points at the same time efficiently.
So I expect that our PPU, our product, is going to solve the inefficiencies that are present in current architectures regarding to irregular memory accesses. I'm expecting that in the next year we are going to be able to provide some very good and industrial strength evidence for the performance boost that we are claiming our product will have.